Okay, remember this whole chapter we have been working on solving quadratics. So I've been giving you a toolbox of ways to solve any sort of x squared, a parabola. So can anybody tell me what was the first way when we were solving quadratics? What did we do first? We graphed it. Perfect. Okay, so our first way was we graphed it. And then we looked to see, what did we look at the graph? Okay, so we graphed it, we found the vertex, but Thomas, what do you say? The zeros, okay, where it crosses the x-axis. All right, then what did we do? It was your most favorite thing to do in math. It's your favorite math F word. Factoring. Yay, factoring, thank you. And so graphing didn't always work, right? If it didn't cross that nice pretty numbers, it made it a little tricky. We got some crazy decimals. Factoring didn't always work because if it doesn't cross the x-axis, then it's not going to factor nicely. And then so we said, okay, what could we do? And that's what we just started with. That was completing the square. So remember, I'm trying to give you a toolbox of ways to solve them. Okay, so it says complete the square, and then today we're going to talk about the quadratic formula. That's the one we've done before. You've seen this guy before. Okay, so those are our 4 methods that we're going to use for right now. And that's probably all we're going to use. All right, so the first one right there at the top, it says derive the quadratic formula from ax squared plus bx plus c equals 0. All right, so we're going to do this by completing the square. So if you notice, this guy right here in the middle of your page is the quadratic formula. I'm going to show you where that comes from by completing the square. All right, so if we're going to complete the square, remember that I can't complete the square with a coefficient out front. So I'm going to divide everybody by a. So I have x squared plus b over ax plus c over a equals 0. And now I'm going to subtract that c over a over to the other side and add in my boxes. So x squared plus b over ax plus my box equals negative c over a plus my box. Okay, so we've divided the coefficient out. We've moved our constant over to the other side. We've added in our box, and now we're ready to fill in our box. So, my box, remember, is b times a half squared. But in this instance, it's b over a, so I'm just going to put b over a in. So this guy is b over 2a squared. So b squared over 4a squared. That's what's going to go in my box. I'm going to try to squeeze it in. All right, Remember, I'm forcing that to factor. So I have x plus b over 2a equals, now this part's a little bit trickier, but we're good with fractions. These guys right here, I can't just put them in my calculator. That's what we've been doing, but I can't put variables into my calculator like that. So instead what I'm going to do is I'm going to get a common denominator. And my common denominator is 4a squared. So I'm going to multiply this guy by another 4 and an a. So I'm going to multiply the top, which is negative c, times 4 and an a. And then I also have my b squared. Notice, really quick, what do you see? I have negative c times 4a plus b squared. And look, I have b squared minus 4ac. So we're getting there. All right, let's squish it together. So I have x plus b over 2a, the whole thing squared, is equal to, and like I said, I'm just going to rearrange it now because we know we want b squared minus 4ac. And now I'm going to take the square root so I have x plus b over 2a is equal to, I took the square root, so I have a plus or a minus, the square root of b squared minus 4 times a times c all over the square root of 4 is 2, and the square root of a squared is a. And now I'm going to subtract my b over 2a. Negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And finally, when we squish it all together and you can sing it to Pop Goes the Weasel, negative b plus or minus square root of b squared minus 4ac all over 2a. You never thought I'd sing to you this early in the morning, did you? A whole song about the quadratic formula? Oh, dang. Whoa. Man, I'm going to have to up my game. I just knew it to Pop Goes the Weasel. Dang. Okay, so that's a lot of jazz to show you where the quadratic formula comes from. Remember, it's just another tool. Okay, so we're going to just pick what works or what they tell us to do, and we're just going to keep solving these guys. That doesn't mean we can't look at a graph. That doesn't mean we can't complete the square. Okay, it's just another method to do it. Okay? All right. So, the solutions of a quadratic equation can be given by this guy right here. Remember, the plus or the minus just tells me that that's how come I can get two of them. I have one that's positive and one that's negative. And remember, if I just get one solution, then that's because my vertex is sitting on my x-axis. Okay? All right, so are you ready to start solving some? Any questions before I go any further? Okay. Yes. Yep. Uh-huh. Yeah, it's the constant. And you just plug it in. Just be careful before you plug things in, get everything on one side of the equal sign. Just like when we are factoring and completing the square, or when you're factoring and graphing, I mean, you have to get everything on one side of the equal sign and set it equal to 0. So like in number 2 here, this guy's equal to 33. before you figure out what c is, set him equal to 0. So this guy is x squared minus 8x minus 33 equals 0. So a is the coefficient of the x squared, so that guy's 1. B is the coefficient of x, so that's negative 8. And c is negative 33. Okay, so let's plug it in. Here's your formula. So x equals, and I got a negative b and he's already negative, so I have a negative negative, if you will, so he's going to be positive, plus or minus square root of b squared minus 4 times 1 times a negative 33. All over 2 times 1. Okay, now, I don't want you to put the radical in your calculator and give me some crazy decimal. That would match kind of like what we were doing when we were graphing. I want the exact answers. So think about when we were solving them with completing the square, we were getting a radical answer or an irrational answer. So what I want to do is I just want to put this part here in my calculator, just without the radical. So here's what I have. I have x equals positive 8 plus or minus, and now I'm just going to put the guy under my radical in my calculator, not the whole radical, just what's underneath it. Negative 8 squared minus 4 times 1 times a negative 33. Notice I didn't put the radical in. Sometimes it'll work out, like the square root of 196. That's one that we actually know, and you feel like, really? Try it. See, it's 14. Okay, if it didn't work out, then you would factor tree it. So here's what I have. I have x equals 8 plus or minus 14 all over 2. This guy works out, so let's actually figure out what 8 plus 14 divided by 2 is. And then we have 8 minus 14 divided by 2. So 8 plus 14. Excuse you, calculator. So 22 divided by 2, so x is 11. And then 8 minus 14 divided by 2 is negative 3. Okay. Okay. Where'd I lose ya? Okay. Be careful with parentheses. So if you type in negative 8 and then you square it, you're going to get negative 64. Sorry for the glare. However, negative 8 squared is positive 64. So we should get 64 right there, plus 4 times 33. So make sure you use, but there's a negative 33. Yeah. Okay. Anything else? All right, ready for another one? Let's try 3. All right, here we go. A is 9, B is negative 24, and C is 16. So x equals negative 24 plus or minus the square root of b squared minus 4 times 9 times 16 all over 2 times 9. Negative is a positive 24. I'm going to put that guy just as he is in my calculator. Make sure you use parentheses. So negative 24 squared, that should be positive when we're going. Minus 4 times 9 times 16. We got 0 all over 18. What about the square root of 0? 0. So this guy ends up with just being 24 over 18, and then that reduces, I'm going to divide them both by 6, so 4/3. So that one we got just one solution because I'm not going to add or subtract 0. So if you get a 0 under the radical, it means this guy's sitting on the x-axis and he's sitting at 4/3, the vertexes. All right. Do you want to do both of these last two ones, or do you just want to pick one? All right, let's do 5. All right, so I have a negative 6 on this side, so I'm going to add 6 to the other side. So 7x squared plus 6x plus 2 equals 0. So A equals 7, B equals 6, C equals 2. So x equals negative b, so negative 6 plus or minus the square root b squared minus 4 times a times c, so 4 times 7 times 2, all over 2 times 7. Negative 6 plus or minus the square root. I'm going to throw that whole thing in my calculator. Make it do the work for you. But be careful with parentheses. All right, now we have to do a little bit of work with this negative 20. So we have negative 6 plus or minus the square root of negative 20 all over 14. What do we know about negatives under radicals? They're imaginary, so it gets to come out as an I. So I have x equals negative 6 plus or minus, and then if I do that, I get I root 20. Can we simplify the square root of 20? Yeah, let's factor tree them. 4 and 5, so a group of 2's can come out. So this guy is negative 6 plus or minus, a 2 comes out, so I have 2i root 5 all over 14. Now, on that last test that we took, some of you missed a point because I have to look to see if there's anything I can reduce. And I love to reduce. See how it makes a heart? Is there something I can take out of all of those? Yeah, they're all even, right? So this guy becomes negative 3 plus or minus I root 5. I ran out of room. All over 7. I'll rewrite that. Negative 3 plus or minus I root 5 all over 7. How many solutions do I have there? Two. Yeah, I have two there. Thanks, Sasha. I have the one with the plus. So I have negative 3 plus I root 5 over 7 and negative 3 minus I root 5 over 7. And remember, anytime it has an I, it's a complex solution. So complex solutions are always in conjugate. There's that word we've heard before. Conjugate pairs. Conjugate pairs just means, it's got the same exact stuff, but the sign in the middle is flipped. So anytime you have an I, you're going to have two of them, and they're going to be conjugates. Okay, let's look at a few other things. We got a 0 under the radical, and I got 1 root. I had a perfect square under the radical, and he was positive, and I got 2 nice, pretty roots. If we would have done this guy, he would have ended up being a radical answer. He ends up with being negative 9 plus or minus root 5 all over 6. But we can determine what kind of answers we get based upon the guy that's under the radical. Okay? So any questions before I talk about the discriminant? Okay, turn the page. What do you mean? Which one? We're left here. He's just this guy. He just stays like that. Yeah, because he's got a radical and he's got an I. So we just simplify him as much as we can and he stays like that. So if I were to graph this guy, JJ, he wouldn't cross the x-axis because he's got an imaginary answer. And here I'll show you. So 7x squared plus 6x plus 2. See how that guy doesn't touch the x-axis? He's got imaginary roots. So he doesn't have real roots, and that's why we've got an I with him. Okay. So let's talk about the discriminant now. So the discriminant is just the value under the radical. Okay, it doesn't include the radicals. So that's what I said, don't just put the guy in your calculator. That part that we were just putting in our calculator is just the discriminant. And based upon what that number is, it tells us what kind of answers we get, or roots, or solutions. Okay, so if my discriminant, the guy under the radical, is positive, remember greater than 0 means it's positive, and it is a perfect square, that would be like number 2. The guy under the radical was 196. He's positive and he's a perfect square. We got 2 real rational roots. 2 nice pretty answers. 11 and negative 3. Okay? If he's greater than 0 and not a perfect square, like 12 or 42 or something like that, it's not a perfect square, we get 2 real irrational roots, meaning he's going to have a radical in his answer. If the discriminant is equal to 0, like this guy, we got 1 real rational root. And if my discriminant is negative, that would be like this guy, negative 20. I get 2 complex or imaginary roots. Okay, so number 5 says find the value of the discriminant for each quadratic equation, then describe the number and type for the equation. All right, so you're just doing that b squared minus 4ac part. So again, I'm just going to list A, B, and C. So A is 1, B is 6, C is 9. So b squared minus 4ac is 6 squared minus 4 times 1 times 9. I'm going to put that guy in my calculator. Again, just use lots of parentheses. They're not, I don't charge you for them. So my discriminant is 0, which means it says find the value of the discriminant for each quadratic equation, then describe the number and type of roots. You might see it say describe the nature of the roots. That means I have one real, rational root. Now, we could go on from this place and actually solve it, but this guy just said find the discriminant. Okay, all right, questions on that one? All right, let's go to B. A is 1, B is 3, C is 5. All right. B squared minus 4ac, 3 squared minus 4 times 1 times 5. Three squared minus 4 times 1 times 5. Negative 11. He's negative. It doesn't matter whether he's a perfect square or not. As long as he's negative, I get 2 complex roots. Okay, try C. See if you can get C. Did you get 80? Now that guy's positive, and he's not a perfect square, so we get 2 real irrational roots. All right, by process of elimination. This one should be nice and pretty. We should get 2 real rational roots. So hopefully you get something that's positive and a perfect square. So let's try it. Be careful with this one when you put it in your calculator because that 11 is negative. So you should get 81. So he's positive and a perfect square, so I have 2 real rational roots. Okay, questions on anything we talked about?